allow for a multi-dimensionality. The next one we talk about using NoSQL as a cache. So here we look at using either an RDBMS or NoSQL as a data warehouse, and we have an extra cache that is sitting on top of this data warehouse. We have a specific cache loaders which will load the data into cache, NoSQL cache, and BI will be talking to the NoSQL. The primary purpose of this kind of pattern is that BI will be used for doing data exploration or interactive analysis by searching the data in the NoSQL. So the NoSQL that support some type of full text search are more primarily the candidates for this. The next one is using the NoSQL as a semantic layer or repository. Here we talk about regular data warehouse or a NoSQL based data warehouse, which is talking to BI, but the BI actually having the repository based on the NoSQL store. That means the semantic layer, that means the metadata, and as well as the BI artifacts will be stored directly in the NoSQL, which will give more freedom and as well as the faster access to those reports. And as and when the BI repository grows, we can also scale the NoSQL. Next, I will talk about the NoSQL modeling patterns that are applicable for the BI landscape. So basically in the modeling, some of the typical considerations that we need to do is we need to start the application model and the NoSQL modeling from the application needs. We need to see what are the use cases that we need to support. Based on that, we need to choose the NoSQL store, and as well as based on that, we should actually also define the model patterns. And also we should understand how the data being accessed. So we should have a very good understanding of data query algorithms. And also we should be very careful with the type of the NoSQL that we select so that we can apply the appropriate modeling patterns. So some of the modeling patterns are denormalization, which is a general concept that we also use in regular data warehouse. So here typically if you look at traditional data warehouse, we have a time dimension. We have a fact table holding the time information, and generally we link them by a Sargate key. So the time dimension will be separately populated in a dimension table, and the fact will be actually linked via Sargate key. But this is actually a relational model, which most of the times introduce lot of trouble in accessing the data or querying the data. In case of denormalization, the proposal is that we actually also bring in the time element into the same table, rather than actually using it as a separate table. And the application can handle the appropriate filtering and query of the time. And then the next one talks about the aggregates. So especially here the nested document structures, they will help us to reduce many-to-many relationship. If there is a document data store, and if we're actually representing, let's say, a person, and for example, an employee and employer as a different documents, we have troubles in actually accessing those two together, because the reason is we have to link them in the application side and access them. But instead of that, if you nest them, we will be able to access them with one single call. And then application side joins. So here we talk about joining on the application side rather than joining on the database data store side. So this is typically or more since we have since there are a lot of technologies to do distributed computing, we should leverage the application side joins in order to actually access the data very fast across multiple document stores. And then atomic aggregates. So here also the idea is that we should here we are trying to introduce some kind of atomicity when modifying a particular set of documents. So the idea is that we create an aggregated or nested document structure. So in case so that we can avoid multi-value updates in multiple documents, and then only focus on a single update on the single nested document. So it will be one transaction, and then we can achieve the atomicity accordingly. And then next one talks about the dimensionality reduction. So we should be able to have, there are multiple techniques available in fact to map a multi-dimensional data into a key value model. So we should leverage them. We should ensure that the damage have been reduced and so that the joints are reduced. And then one of the typical scenario is that most of the NoSQL data stores, they will not support indexing. So indexing will help as a quicker access to the data. So here in this case, what we are trying to say is we maintain a separate indexing table in a different NoSQL store, and then this can allow us to do a faster access of the data. And then one of the most common use cases in a key value store or any other NoSQL store is the composite keys. So that will help us to do a multi-dimensional query. And then I will also slightly talk about the semantic models here. So semantic model, as I was explaining, it's primarily a business representation of the technical data in the database. And it sits between data and end user so that it can translate the database structures into a meaningful business objects. And it helps to run the queries against appropriate stores or databases. And then also it serves as a single source of truth for the business users, irrespective of number of data sources or variety of data sources. So here I propose that the semantic models can be modeled in NoSQL in two different ways. One is using the graph NoSQL stores, or the other way is actually using an RDF semantics in a documented data store. So this will help us to actually model a relational style database in NoSQL store, because traditionally most of the BI repository or semantic models are RDBMS oriented because they are more relational in nature. So even this can be modeled with a graph databases here. And that can also help us even to achieve some level of ACID behavior. So the summary is that so we should, when we are looking at BI and NoSQL, we should look at first of all evaluate the appropriate NoSQL store so that we fulfill the application needs. And we also have to remember the fact that the SQL is not going away. So SQL needs to be kept because ad hoc query is a serious limitation in NoSQL stores, and SQL will still remain there to serve the needs. And the future BI is expected to have a polyglot persistence. What this means is we might have both NoSQL or multiple variants of NoSQL along with multiple variants of SQL databases in the same BI suite to serve different BI use cases. And then also the modeling is very strongly depending on the application needs and as well as the type of the NoSQL stores. So with this, I will wrap up the session. So I think it's time for the Q&A. So I will look forward for some questions.